The science behind the blue sky. When we look up on a clear day, the sky gifts us with a spectacle of blue that seems infinite. But have you ever wondered why this happens? The answer lies in a fascinating physical phenomenon known as Rayleigh scattering, which describes how light interacts with particles in our atmosphere. Sunlight, although it appears white at first glance, is actually made up of a mixture of colors corresponding to different wavelengths: red, orange, yellow, green, blue, indigo, and violet. Each of these colors has distinct properties and behaves differently as it travels through the Earth's atmosphere. When sunlight comes into contact with air molecules and other small particles in the atmosphere, scattering occurs. This process is more effective with shorter wavelengths, such as blue and violet. Due to its shorter wavelength, blue light scatters in all directions more than the other colors when it collides with air molecules. This means that although the white light from the sun contains all colors, blue is the one that scatters the most and is therefore what we see most prominently. However, we do not see the sky as completely violet, even though this color also scatters. This is because our eyes are more sensitive to blue and less so to violet. Additionally, some of the violet light is absorbed by the ozone layer in the atmosphere. So what we perceive is a beautiful blue sky. The phenomenon doesn't stop there. When the sun is low on the horizon during sunrise or sunset, its light has to travel through a greater amount of atmosphere before reaching our eyes. During this longer journey, shorter wavelengths, blue and violet, scatter so much that they hardly reach us. Instead, colors with longer wavelengths, such as red and orange, dominate, giving us those spectacular sunsets filled with warm tones. Atmospheric conditions also play a crucial role in how we perceive the sky. Factors such as the presence of dust, smoke, or humidity can alter how light scatters. For example, on days with high pollution or after wildfires, we may see more reddish or orange skies due to the increased number of suspended particles. Rayleigh scattering not only explains why we see a blue sky during the day, it is also responsible for other optical phenomena like rainbows and halos around the sun or moon. When it rains and there are water droplets in the air, these act like tiny prisms that break white light into its component colors, creating beautiful rainbows. In summary, the blue color of the sky is a direct result of how sunlight interacts with particles in our atmosphere. This phenomenon reminds us that something as ordinary as looking at the sky is filled with science and beauty. As we continue to explore the secrets of the natural world, there is always more to discover about how our environment works and the phenomena that surround us.